When we think of prehistoric creatures, our minds often jump to the giants. We imagine the mighty Tyrannosaurus rex with its bone-crushing jaws or the long-necked Brachiosaurus reaching for the tallest trees. These animals are famous for a reason. They were incredible beings that ruled the ancient world. But the history of life on Earth is far more bizarre and varied than just these well-known titans. For every familiar dinosaur, there were dozens of other creatures that were so strange they seem like they belong in a science fiction movie. The fossil record is a treasure chest filled with nature's wildest experiments, showcasing animals with features and lifestyles that challenge our very understanding of what is possible. The deep past was a laboratory where evolution was constantly trying out new ideas. Some of these ideas were incredibly successful and led to the animals we know today. Others were fleeting, resulting in creatures that existed for a short time before vanishing forever, leaving behind only their fossilized remains as clues to their existence. These fossils tell stories of a planet teeming with life forms that are almost beyond our imagination. We find creatures with teeth arranged in spirals, fins shaped like anvils, and mouths designed like vacuum cleaners. These animals were not mistakes. They were perfectly adapted to their specific environments and times, filling niches that no longer exist in our modern world. Exploring these oddities of the past is like being a detective solving an ancient mystery. Every bone, every tooth, and every fossilized footprint provides a piece of the puzzle. Paleontologists work tirelessly to reconstruct these animals, figuring out not just what they looked like, but how they lived, what they ate, and why they developed such unusual features. Did a strange hump on a dinosaur's back help it stay cool? Did a set of bizarre fangs serve as a weapon or a tool for finding food? The answers to these questions reveal the incredible creativity of evolution, and paint a much richer and more interesting picture of prehistoric life than we ever thought possible. This journey will take us back millions of years to meet some of the strangest animals that have ever lived. We will travel to ancient oceans, dense forests, and vast plains to uncover the secrets of these forgotten beasts. From sharks with circular saws in their mouths to tiny dinosaurs that look like a cross between a parrot and a porcupine, these creatures demonstrate that the real history of our planet is more wondrous and surprising than any story we could invent. Prepare to meet some of the most peculiar residents of ancient Earth, and see for yourself just how weird the world used to be. Long before the dinosaurs, the ancient oceans were home to some truly fearsome predators. One of the most peculiar was a shark-like fish called Helicoprion. This creature swam in the seas around 280 million years ago, during a time known as the Permian period. Fossils of Helicoprion have been found all over the world, from North America to Russia and Australia, showing it was a widespread and successful animal. For many years, scientists were baffled by its fossils. The only parts that preserved well were its teeth, which were arranged in a unique and mysterious spiral shape. This strange feature has earned Helicoprion the nickname buzzsaw shark, and it makes it one of the most unforgettable creatures of the prehistoric world. The most striking feature of Helicoprion was, without a doubt, its tooth whorl. Imagine a circular saw blade made of teeth, and you have an idea of what its lower jaw looked like. As the animal grew, new teeth would form at the back of the spiral, pushing the older, smaller teeth towards the center. This created a continuous spiraling conveyor belt of sharp points. For over a century, paleontologists debated where this tooth whorl was located. Some thought it was on the dorsal fin, others on the tail. It wasn't until modern scanning technology was used on a well-preserved fossil that we learned it was housed inside the lower jaw, a truly unique arrangement among all known animals. So what was this incredible buzzsaw of teeth used for? The evidence suggests that Helicoprion was a formidable hunter of soft-bodied prey. Unlike sharks today that have rows of replaceable teeth, Helicoprion's whorl was a permanent fixture. When it closed its mouth, the spiral of teeth would rotate slightly, slicing through its food like a knife. Its main diet likely consisted of squid, ammonites, and other shell-less cephalopods that filled the Permian oceans. The buzzsaw would have been a highly efficient tool for cutting up slippery and soft prey, ensuring the shark could eat its meal quickly and effectively. It was a specialized hunter with a one-of-a-kind weapon. Helicoprion eventually went extinct during the Great Dying, the largest mass extinction event in Earth's history, which wiped out most life on the planet. Despite its strange appearance, this creature was a marvel of evolution, a perfect example of how life can adapt in unexpected ways. It shows us that the history of sharks is not a simple straight line but a sprawling family tree filled with bizarre branches. The buzzsaw shark is a powerful reminder that the ancient world was full of creatures that pushed the boundaries of biology, leaving us with fossil mysteries that continue to captivate and challenge our imaginations today. Let's travel even further back in time to about 370 million years ago during the Devonian period, often called the Age of Fishes. The oceans of this era were a testing ground for all sorts of new and experimental body plans. Living in these waters was a small shark named Stethocanthus, which grew to be only about 2 feet long. At first glance it might have seemed like any other small ancient shark, but Stethocanthus had a secret weapon, or perhaps a secret billboard, that made it stand out from everything else in the sea. This bizarre feature was located on its back, where its dorsal fin should have been. Instead of a normal pointed dorsal fin like the sharks we see today, male Stethocanthus sported a structure that looked like a flat-topped anvil or an ironing board. This fin was covered in rough, tooth-like scales called denticles, giving it a texture like sandpaper. As if that wasn't strange enough, the top of its head was also covered with a matching patch of these same rough denticles. This unique combination of an anvil-shaped fin and a bristly head patch has puzzled scientists for decades. It's a feature that has no modern equivalent, making Stethocanthus one of the true oddballs of the shark family tree. The purpose of this strange anvil fin is still a topic of debate among paleontologists. It was likely not used for swimming, as its flat shape would have created drag in the water. One popular theory is that it was used for display, much like a peacock uses its elaborate tail feathers. A male Stethocanthus might have used its fin to attract a mate, with the most impressive anvil belonging to the most desirable male. Another idea is that it was used in territorial disputes to intimidate rivals. Perhaps 2 males would face off, showing off their fins to see who would back down first. Some have even suggested it could have been used to scare away larger predators. Another fascinating theory suggests the fin might have been used for docking. Perhaps the shark could attach itself to the bellies of larger sea creatures, using the rough patches on its fin and head to get a firm grip. This would have allowed it to catch a ride, saving energy as it traveled through the ancient seas. Whatever its true purpose, the anvil fin was a bold evolutionary statement. Stethocanthus shows us that even early in their history, sharks were incredibly diverse. They weren't just simple killing machines. They were complex animals with unique behaviors and adaptations that we're only just beginning to understand. When we picture plant-eating dinosaurs, we usually think of gentle giants. But the prehistoric world was full of surprises, including a small herbivore that looked anything but gentle. Meet Pegomastax, a tiny dinosaur that lived during the early Jurassic period, around 200 million years ago. Its fossils were discovered in South Africa, and this creature was no bigger than a house cat. What made Pegomastax so strange was its combination of features. It had a short, parrot-like beak, a body covered in bristle-like quills similar to a porcupine, and most surprisingly of all, a pair of sharp, vampire-like fangs at the front of its mouth. The appearance of Pegomastax would have been truly bizarre. Imagine a 2-foot-long, 2-legged creature scurrying through the undergrowth, covered in spiky quills for protection. These quills were likely a defensive adaptation, making the little dinosaur a prickly mouthful for any predator that tried to eat it. Its beak was perfect for nipping off leaves and stems, but the fangs have long been a puzzle for scientists. Why would a plant eater need such sharp, prominent canine teeth? They seem more suited for a carnivore than an animal that eats ferns and seeds. This contradiction is what makes Pegomastax such a fascinating subject of study. The leading theory about the fangs is that they were not for eating meat, but were used for self-defense or for display. When threatened, Pegomastax could have opened its mouth to flash its sharp teeth, warning off potential attackers. The fangs might have also been used in fights with other members of its own species, perhaps competing for territory or mates. In addition to the fangs, Pegomastax had powerful jaws and grinding teeth at the back of its mouth. These were used to crush tough plant material, like seeds and nuts. In this way, it filled a similar ecological niche to modern rodents, even though it was a reptile. Pegomastax belongs to a group of dinosaurs called heterodontosaurids, which means different-toothed lizards. This name is very fitting, as these dinosaurs were known for having several different types of teeth in their jaws, a rare trait among reptiles. Pegomastax is perhaps the weirdest member of this already weird family. It challenges our simple classifications of herbivore and carnivore, showing us that nature doesn't always follow neat and tidy rules. This little, fanged, porcupine dinosaur is a perfect example of how evolution can produce wonderfully strange combinations to help an animal survive in a competitive world. Pterosaurs were the flying reptiles that soared through the skies during the age of dinosaurs. While many people think of them as flying dinosaurs, they were a completely separate group of animals. Just like the dinosaurs on the ground, pterosaurs came in a huge variety of shapes and sizes with many strange adaptations. One of the most unusual of all was Pterodaustro, which lived about 105 million years ago during the Cretaceous period. Its fossils have been found in South America, particularly in Argentina. Pterodaustro had a wingspan of about 8 feet, but it was its mouth that truly set it apart from all other flying reptiles. Pterodaustro is sometimes called the flamingo pterosaur for a very good reason. It had a long, upward-curving beak, but the strangest part was inside. Its lower jaw was filled with nearly 1,000 long, thin, bristle-like teeth, forming a dense sieve or comb. These teeth were not for chewing or tearing. Instead, they were designed for filter feeding. Pterodaustro would have waded in shallow lakes and lagoons much like a modern flamingo. It would have skimmed its lower jaw through the water, using its incredible teeth to strain out tiny plankton, small crustaceans, and other microorganisms for food. This feeding strategy is very rare among reptiles, making Pterodaustro a true evolutionary marvel. The comparison to flamingos might go even deeper than just their feeding habits. Some scientists believe that the tiny crustaceans Pterodaustro ate could have been rich in pigments called carotenoids. In modern flamingos, these pigments are what give their feathers their vibrant pink color. It is possible that Pterodaustro was also pink, turning the color of the food it ate. Imagine flocks of these bizarre pink flying reptiles gathering at the edges of ancient lakes. It would have been a spectacular sight, a prehistoric scene that mirrors the flamingo flocks we see in Africa and South America today. The discovery of Pterodaustro completely changed our understanding of the diversity of pterosaurs. It showed that these flying reptiles were not all fish eaters or insect eaters. They had evolved to fill a wide range of ecological roles, including some that are now occupied by birds. Pterodaustro's highly specialized lifestyle demonstrates the incredible adaptability of life in the Mesozoic era. It was a creature perfectly designed for its environment, using a unique set of tools to carve out a living. This bristle-toothed flyer is a testament to the strange and wonderful paths that evolution can take. Not all dinosaurs were huge and terrifying. Many were small, fast, and feathered, looking more like strange birds than giant lizards. One of the most peculiar of these was Mononychus, a small dinosaur that lived about 70 million years ago in what is now Mongolia. The name Mononychus means one claw, and it perfectly describes the animal's most defining feature. This creature was only about 3 feet long, with long, slender legs built for running. It was covered in a coat of simple, hair-like feathers, which would have kept it warm in the cool desert nights. But its arms were what made it truly unique in the dinosaur world. Mononychus had incredibly short and stout arms, so tiny that they were almost useless for grasping or reaching. At the end of each arm was a single, large, powerful claw. It had no other fingers, just this one robust digit. For a long time, scientists wondered what such a strange limb could possibly be used for. An animal with long legs for running but tiny arms with one giant claw presents a real evolutionary puzzle. It clearly wasn't for fighting off large predators or for catching prey. The answer likely lies in what Mononychus ate and how it found its food. The most widely accepted theory is that Mononychus was a specialized insectivore, an animal that eats insects. Its strong single claw would have been the perfect tool for breaking into hard termite mounds or digging into rotten logs to find grubs and other insects. Much like a modern-day anteater or aardvark, which also have powerful claws for digging, Mononychus would have used its specialized forelimbs to access a food source that other animals couldn't reach. Once it broke open a nest, it could have used its long, slender snout and small teeth to slurp up the insects inside. This lifestyle would explain its strange mix of features. Mononychus is part of a family of dinosaurs called the Alvarezsaurids, which are known for their bird-like features and unusual arms. These dinosaurs show a fascinating evolutionary trend towards smaller bodies, longer legs, and highly specialized forelimbs. They represent a successful group of small, insect-eating dinosaurs that thrived in the late Cretaceous. The discovery of Mononicus and its relatives has helped paleontologists understand the incredible variety of niches that dinosaurs filled. It reminds us that for every giant T-Rex, there were countless smaller, stranger creatures scurrying underfoot, each with its own unique story of survival. Sauropods were the largest animals to ever walk the Earth. These long-necked, long-tailed, plant-eating dinosaurs are famous for their immense size. But not all sauropods were alike. One member of this group, Amargasaurus, broke the mold in a very dramatic way. This dinosaur lived in the early Cretaceous period, about 125 million years ago, in what is now Argentina. Compared to its gigantic cousins like Argentinosaurus, Amargasaurus was relatively small, measuring about 33 feet long. But what it lacked in size, it more than made up for with one of the most spectacular and bizarre features ever seen on a dinosaur. Running along its neck and back was a double row of tall, sharp spines that projected upwards from its vertebrae. These spines were longest on its neck, creating a striking and formidable appearance. For years, scientists have debated the function of these incredible structures. One early idea was that the spines supported a large sail of skin, similar to the sail on the back of another dinosaur, Spinosaurus. This sail could have been used for display to attract mates, or to regulate its body temperature by absorbing or releasing heat. However, the spines on Amargasaurus were more like sharp spikes than a flat frame. A more recent and widely accepted theory is that the spines were covered in a sheath of keratin, the same material that makes up horns and claws. This would have turned them into a dangerous defensive weapon. The double row of sharp spikes along its neck would have made it very difficult for a predator to attack. Any carnivore trying to bite its neck would have risked being impaled on these formidable horns. This spiky defense would have been crucial for a medium-sized sauropod living in a world with large predators like the Carcharodontosaurids. The spines may have also been brightly colored for display, serving a dual purpose of defense and communication. Amargasaurus forces us to rethink our image of sauropods as slow, defenseless giants. It shows that some members of this group evolved active and impressive defensive structures. It was a walking fortress, a plant eater that was not to be trifled with. The discovery of Amargasaurus highlights the diversity within the sauropod family, and proves that even the most familiar groups of dinosaurs had strange and surprising members. This spiky-necked wonder is a testament to the evolutionary arms race between predators and prey, a battle that produced some of the most visually stunning animals in Earth's history. The period just after the Permian-Triassic extinction, the greatest mass extinction of all time, was a strange new world. Life was recovering, and new creatures were evolving to fill the empty ecological niches. One of the most bizarre animals to emerge during this time, around 247 million years ago, was a marine reptile called Atopodentatus. Its fossils were first discovered in China, and the initial reconstructions were truly puzzling. The first fossil was crushed in a way that made its mouth look like a vertical zipper filled with teeth, a feature never before seen in any animal. This initial interpretation was so strange it seemed impossible. However, the discovery of more complete fossils revealed the true, and arguably even weirder shape of Atopodentatus's head. It did not have a zipper mouth. Instead, it had a wide, flattened, hammer-shaped snout. The front of this hammer was lined with small, chisel-like teeth, while the rest of its jaws were filled with hundreds of tiny, needle-like teeth. This unique dental arrangement immediately told scientists that Atopodentatus was not a predator of large fish. Instead, it was something much more unusual, the earliest known herbivorous marine reptile. Its strange mouth was perfectly adapted for a very specific way of feeding. Atopodentatus likely used its bizarre hammerhead snout to scrape algae and other plant matter from underwater rocks. The chisel-like teeth at the front of its mouth would have helped it shear the vegetation off the surfaces. Then it would have sucked in the mouthful of water and plant material. The needle-like teeth along the sides of its jaws would have acted like a sieve, trapping the food inside while allowing the water to be pushed back out. This feeding method is similar to how some modern marine iguanas feed, but no other animal in history has ever developed a hammer-shaped head for this purpose. The existence of Atopodentatus is significant because it shows how quickly life began to specialize after a catastrophic extinction event. It was one of the first reptiles to return to the water and adopt a plant-based diet, a niche that had been left vacant. This hammer-headed reptile is a prime example of convergent evolution, where different animals independently evolve similar solutions to a problem, but it also showcases the unique and unpredictable paths that evolution can take. Adaptations is a true original, a creature that looks like it swam right out of a fantasy novel, proving that the recovery of life can be just as weird and wonderful as its origins. Our journey through the prehistoric world has introduced us to just a handful of the countless strange creatures that once roamed our planet. From the buzzsaw-mouthed helicoprion to the fanged and quilled Dunkleosteus, these animals defy our expectations and expand our understanding of what life can be. They show us that the past was not a monolithic era of giant lumbering beasts, but a dynamic and vibrant world filled with an incredible diversity of forms. Every fossil discovery adds a new character to this amazing story, each with its own unique set of adaptations and its own tale of survival in a world very different from our own. The strangeness of these creatures is a powerful lesson in the creativity of evolution. Life on Earth has always been a grand experiment, constantly testing new designs and strategies. The anvil fin of Stethecanthus, the single claw of Mononychus, and the hammerhead snout of Adaptations were not mistakes or failed designs. They were brilliant solutions to the challenges of their specific times and places. These animals thrived for millions of years, perfectly suited to their environments. Their fossils are a record of nature's ingenuity and a reminder that there is no single right way for an animal to look or behave. As paleontologists continue to explore the fossil record, we will undoubtedly uncover even more creatures that are stranger than anything we can currently imagine. Each new bone and each new fossil site holds the potential to rewrite a chapter in the history of life. We are still only scratching the surface of understanding the full and incredible story of our planet's past. The animals we have met here are ambassadors from lost worlds, inviting us to look beyond the familiar and embrace the weird and wonderful history that has shaped life on Earth. They challenge us to keep asking questions and to keep digging for answers. The world of today is just one frame in the long movie of life's history. The past was filled with astonishing life forms that show us the boundless possibilities of biology. These prehistoric oddities are not just curiosities, they are a vital part of our planet's heritage. They teach us about adaptation, extinction, and the endless cycles of change that define life on Earth. The next time you think about prehistoric animals, remember that for every T,